Hey everyone, welcome back to the channel. I hope you are doing extremely well. So today we are going to solve the problem reverse a linked list in groups of size k from the SD sheet. So the problem states that you'll be given a linked list and your task is to reverse the nodes of linked list of group of size k. K will also be given to you, and after that you need to return its modified list. So let me explain you the problem in brief. So assume this is the given linked list and k is given as 3. So what they are asking you is take all the groups of size 3. So these are the groups of size 3 consecutively if you take it, and the last group will be left out with a size of 2. So do not take it. So the first group and the second group should be reversed within themselves, not completely within themselves. So that makes the resultant list to be 3, 2, 1, and after that 6, 5, 4, and then a 7, 8. So you did not reverse the last part. You only reverse the first part within itself and the second part within itself. Now once you have done this, you have to return the head of the modified linked list. So before we move on to the next approach, I wanted to introduce you to something very big. Now, Unacademy has tied up with CodeChef to launch competitive programming on their platform. In this platform, you'll be learning from different educators. Now, these educators are world's best programmers who have been to ICPC World Finals. Also, they have won medals at IOI, and some of them are also working at the top product-based companies. So currently, Unacademy is hosting a lot of free live classes on their platform, so you can probably try them out. Along with this, they have come up with a subscription plan. Now, in this subscription, you'll be getting interactive sessions. Now, this means they'll be having live classes where you can interact with the educators directly in the live class. Along with that, you'll be having structured courses. Now, they will be having courses for beginners, intermediates, as well as the advanced people. So, there will be live classes throughout the year. You can join any of the course or any of the class that you feel to join, and there will also be recordings of the classes so that you can watch it again if you want to of any given live class. Along with this, they're giving you teaching assistants who will be clearing all your doubts that you'll be facing. So the subscription comes up in 3 variants. So if you want to enroll this and you want to get an additional discount of 10%, you can use the coupon code take you forward. Do check it out. The link will be in the description. Now this is a lead code hard problem. Generally, linked list problems are easy. If this is marked as hard, this is real hard problem. So make sure your concepts for linked list are very clear before you start with the approach of this problem. Because if your pointer and everything concepts are not clear, then you'll not be understanding this. So make sure your concepts are super clear before you start off with this problem. So how are we going to solve this problem? At first, let's draw the resultant linked list. So at first, let's observe. This is the first group of size 3. This is the second group of size 3. So what can you see? 1 is pointing to 6, right? Then this 2 is actually pointing to 1, correct? And this 3 is actually pointing to 2. So if I just look at in a shorter perspective, what I can say is if I can reverse this link and if I can reverse this link, I think it should work. Just for a particular group of size 3, this should work. And this 1 to 6 can be taken care of laterly. So as of now, our main criteria is to solve this problem group wise. We have 2 groups over here. So for the first group, we have to reverse 2 links. Just think it in that way. You have to reverse 2 links. So if k is given as 3, you're going to perform 2 operations. In a very, very higher level, you're going to perform 2 operations. So let's discuss this. How are you going to perform this? At first, what you're going to do is count the length of the linked list. And how are you going to do this? You're going to take a cur as a dummy node, and after that you're going to take a counter. So initially the counter will be 1 when it stands at head. After that cur goes over here, counter becomes 2, and so on. At the end, when the cur goes to the last node, it becomes 8. After this, when cur goes over here, it's over. So the counter is 8. So what I can say is the length of the linked list is 8. So at first you need to compute the length of the linked list. So the length of the linked list is 8. So what I know is I will be having 8 by 3, that is 2 groups of size 3. So at first let's do it for the first group of size 3. So initially what you do is you create a dummy node and assign pre to that dummy node and assign the next of the dummy node to 1 as of now. As of now, assign the next of the dummy node to 1. And for the first group of size 3, let's perform the operation. So on the higher level, I told you we need to perform two operations, correct? One is to reverse this link, the other is to reverse this link. So actually it is k minus 1 operations if you talk in general terms, because if the group is of a size 3, you're gonna reverse two links. So let's reverse one link at first, and then we can probably figure it out for the next. So at first, before starting any reversing of the link, what you need to do is make sure you take a node curve and stand it right next to the dummy's next, that is the first node of any of the linked list, that is to the first node, that is the head, and you take an x, again a dummy node pointing to the next of the curve, correct? So that is what you do. Now let's start reversing the first link. So what we are gonna follow is, at first break this link and point the next to 3. Please stay with me, you will understand. So this can be written as curse next is pointing to next is next. Now, what is your task? Your task is actually to point 2 to 1. Where is 2 pointing to? 2 is pointing to 3. So you need to make sure 2's this link is broken and this link is associated. Basically, 2 should point to 1. That is your first motive. So how are you going to do this? I think that's super simple. It's nexus next is pointing to pre's next. I'll tell you why I'm writing pre's next and not cur. Now once you have done this, what you do is you take this pre's next and point it to the next. Basically, I'm keeping a track of the previous variable. Firstly, pre's next was pointing to 1. Now pre's next will point to 2. At the next step, pre's next will point to 3. That is what I'm trying to keep a track. So this step can be written as pre's next is gonna point to next, because next is going to be your next current element. After this, you take the next and move it forward, that is to 3. So if I try to write it, I cannot write next is equal to next is next, because that's pointing to 1. So cur is keeping the track of the next. So what you can write is next is pointing to cur's next. So this is your operation that you did to reverse this first link. After this, you need to make sure 3 also points to 2, because that is also a part. So what you do is again perform this same number of steps. So let's do it. So curse next should points to next is next. So let's do it. So let's break curse next and let's point it to the next. After this, what you're doing is next is next. So next is next was pointing to 4. And you know 3 has to point to 2. So you just break it down and point it to 2. So let's cross this off. After this, you know pre has to keep a track of the previous one. So now pre's next, instead of pointing to 2, will point to 3, because that is your next previous one, or the current one, you can say it. After this, next is gonna move to 4. So you have successfully reversed the 2 individual links. And now if you carefully observe, your dummy node is pointing to 3, correct? Your dummy node is pointing to 3, that's perfect. And 3 is pointing to 2 and 2 is pointing to 1, and 1 is actually pointing to 4. Forget about this part, but this portion has been sorted and you have it in order. Now you just need to perform the next set of operations for the right half. I think it should be done. So at the next step, what you do is the count was 8. Now since you performed for a particular size 3, you decrease the size to 5 now, because you're only left with this right half, that is a linked list of length 5. So let's do it for the length 5. So the next group is this, for which you are going to perform operations. But before that, you have to take care of your curl, next, and everything. Now this is your next group. Now before doing anything, what you do is you take your pre. Now remember one thing, I'm not moving the dummy node. Dummy node stays as it is, and dummy node is pointing to 3. That is basically this portion stays intact. I'm not doing anything to it. I just take the pre, and what I do is I take it to curl. So pre stands at 1 now. So what I can say is pre is actually standing at this one, right? Over here there are a lot of links which are haphazardly written, so you are not understanding, but pre has been taken to 1. So pre now stands here. So at the next step, what you do is you take your curl, and curl should be pointing to pre's next. So what's pre's next pointing to? 4. So curl will be standing over here, and what you're going to do with the next is next should be pointing to the next of curl. So again you can see a pattern developing. What we are trying is curl is always standing at the first node of any group of size k, and next is standing at the second node of any of the group of size k. Now you know what you need to do. You need to reverse these two links. Again you have to perform these operations twice, and I think you should be done. So at first, what's the step? This curse next is gonna break, and curse next is gonna point to 6. So let's point it. What are you waiting for? After this, next is next. That is, this is gonna break, and this is gonna point to 5, 4. After this, you have to keep track of this 5. Now pre is next. Instead of pointing to 4, is gonna point to 5. Perfect. At the next is gonna move to the 6. So I have successfully reversed the first link, and 1 is pointing to 5, you can see. Okay, let's do the next step. Again in the second iteration, I need to figure this out. So at first, curse next is gonna point to 7. Perfect. So 4 is pointing to 7. After this, next is next. So next is next was pointing to 7. So this gets broken, and it will point to pre's next, that is 5. Done. Next step, pre's next is going to point to next. So this is going to break, and this is going to point to 6. Perfect. Next, we'll go to 7 now. Once the two operations are done and these two links are reversed, what you do is you reduce the size by 3 more. So the size now reduces to 2. So what you know is the right half is now left with only 2. Correct? It's only left off with a size 2. So I'm for sure that the right half cannot have a group of size 3. So I'm gonna stop. That's something very important to observe. When you completed the iterations for the last group, see how does this work. At first you did this. Now where is 1 pointing? Just figure this out. At the end 1 is pointing to 6. That is what you wanted. Where is 6 pointing? To 5. Yes, that is what you wanted. Where is 5 pointing? To 4. Yes, that is what you wanted. Now where is 4 pointing? You make sure that 4 was pointing to 7 by making sure that curse next was always pointing to next as next. So in this order, I can say that this portion was also satisfied, and this portion will not be done anything because this is not of a group of size 3. So what I can say is, who is the head of that new linked list? Because the linked list has been modified. What I can say is I kept a dummy node that was always pointing to the next. Correct? So where is the next pointing? To the 3. Correct? If you remember over here properly. So what I can return is the head of the new linked list. That is nothing but dummies next is going to be my head of the linked list, which will be the head that I'm going to return. So if I talk about the complexity, it's going to be n by k. That is for the number of groups. And for every group, you're doing k iterations. That is basically reversing k minus 1 links. So if I just cut it off, it's going to be big O of n. And if I talk about the space complexity, I'm not using anything except a dummy node. So I can call it as a big O of 1 space complexity. So now let's discuss the C++ as well as the Java solution to this lead code hard problem. The code's going to be very simple. Now what you know is, if k is equal to 1 or if the linked list is empty, you cannot reverse an empty linked list or a single node linked list. So you simply return. After that, what you do is you create a dummy node. If you remember, we created a dummy node. So create a dummy node and make sure you point next of dummy nodes to the head of the given linked list. Once you have done this, for the first iteration, assign cur to dummy. After that, assign next to dummy and pre to dummy. It's just declaring three different nodes which we are going to use in the later half. At the first step, what we did, we counted the number of nodes in the linked list, that is, find the length of the linked list. So what I do is I initialize count as 0 and I keep on moving curve unless until it reaches the last node, and I keep a counter which counts the number of nodes. So this counts the length of the linked list. So count is storing the length of the linked list. And what I do is I keep on iterating till the right half or the count is greater than equal to k. If you remember, at first 8, then 5, then 2. So I keep on doing it till it is greater than 3. And inside that, I'm going to do k minus 1 iterations. Correct? So at first, what we always did was made sure curve was standing at the first node of that linked list of size 3. So cur is always pointing to pre's next. So if you remember, we assigned pre to dummy. So dummy's next is going to be the first node at the first time. After that, next will always be cur's next, because we need to make sure that next is the second node of the linked list of a group of size k. After that, what you do is you do k minus 1 iterations. And these iterations I've already explained in the explanation, so I don't need to explain it again. Just keep on doing this, and this will make sure that those links are reversed. And once you have done the k minus 1 operations, make sure the pre is moved to cur, that is the last node of the reversed group of size 3. After that, you're going to reduce k from the count that we always did, from 8 to 5, from 5 to 2. And once you have done that, again come back and do the same task and keep on doing this for every group of size k. Once you have done this, you know who is the head of the new modified linked list, that is dummy's next. Simply return it and you get your answer. Now in the Java solution, you're given the head of the linked list as well as k. So at first you check for the base condition. If the linked list is empty or if the linked list is null, we know that we don't need to do anything for that. So we simply return the head. After that, you create a dummy node. If you remember, we created a dummy node, and make sure you point its next to the initial head of the given linked list. After that, declare three variables which we will be requiring in our later half, that is cur, next, and pre, and make sure you assign it to dummy as of now. After this, we have to compute the length of the linked list, because that will help us to know how many groups of size k are there. So you take count as 0 and keep on iterating cur till it doesn't reaches the last. So this will give you the length of the linked list. After this, you have to iterate till count is greater than equal to k. Now what does that mean? You have to iterate till you have groups of size greater than equal to k. So at first count will be 8, then count will be 5, then count will be 2. And whenever it becomes 2, you're going to stop. So that will signify that you have two groups of size 3 for the example that we took. Now, you know, for every group of size k, you need to make sure that cur is standing at the first node of that group and next is standing at the second node of that group. So cur will always be pointing to pre's next, because pre is going to point to the previous node of the previous group. So cur is going to be pre's next. After that, next is going to be cur's next, basically the second node. And after that, you have to reverse k minus 1 links. So you loop for k minus 1 time. And to reverse every link, you perform these 4 steps. I've already explained you these 4 steps. Once you have done this, what you make sure is pre again goes back to cur. Why is that? So that pre stands at the last node of the previous reversed group of size k. And after that, if count was 8, you subtract 3 from it and count becomes 5. That is the step that I'm doing over here. And you keep on doing this for every group of size k. And once all the groups of size of k has been reversed, you can return dummies next. Now, why do I return dummies next? Because that will be pointing to the head that you would have got, and that will be your answer. So this was it for this lead code hard problem. Just in case you understood the entire explanation as well as the code, please make sure you like this video. And if you're new to our channel, make sure you subscribe to it. With this, I will wrap up this video. Let's meet in the next video. I'll be discussing the solution of the next problem in the SDE sheet.